Now come to the next effect of conjugation and resonance, that is basic strength, relative basic strength of the given species. As you know, a species is basic due to the donation of the lone pair of electrons. So electrons donation is basic. For example, all nitrogen species, nitrogen has lone pair of electron on it. If 3 valencies of it is satisfied, the lone pair of electron is present on that, and that can be donated to the needed atom or group of atoms. And that in that situation, the N nitrogen atom behaves as the base because of the donation of the lone pair of electrons. So if nitrogen donate lone pair of electrons easily, then it will be more basic. If it donates the lone pair of electron hardly, then it will be less basic. Not in the terms of only nitrogen, in other groups or group of atoms it is also the same. So when a species gives electrons easily and it becomes more basic strength, if it gives hardly the lone pair of electrons, then it is less basic. Let me explain more, right? So here, if a species gives lone pair of electrons easily, then it is more basic. If it donates hardly, the lone pair, then it is less basic. Right? For example, let me take an example. With a suitable example, I am going to show you each and every concept. So here, let's suppose here is NH3, right? And here is R NH2, and here is NH2 with benzene ring, that is aniline, right? So here 3 species are given. We have to identify the basic strength order. So in this, the 3 hydrogen atoms are attached, right? Only hydrogen atom, that means it is normally a ammonia molecule. The lone pair of electron is present, right? And this is the ammonia derivative. These twos are ammonia derivative. One hydrogen is substituted by alkyl group in this and benzene group in this to give the relative species. So here, this alkyl group shows plus I effect. That means it increases the electron density on an atom, by which lone pair of nitrogen can be easily donated by repulsion. Right? That means this shows plus I effect. This increases the electron density on nitrogen atom. When electron density increases. So plus I effect it shows. So lone pair of electron on nitrogen atom feels some repulsion, and these light lone pair can be easily donated. Because the mutual repulsion takes place between the electron density and the lone pair of electron present on the nitrogen atom. Now come to this species. This is the benzene ring. Here the conjugation between the lone pair and the pi electrons of the benzene ring. So delocalization of the pi electron within the benzene ring takes place, and this lone pair hardly present for the species to donate it. So it means it is hardly present to donate. That means more easily in this species the lone pair is given. So that means RNH2 is more basic than the ammonium neutral molecule, and here the delocalization takes place. So lone pair of electrons hardly available. So this is the least basic. Basic strength, base strength order. Hope that each concept and every concept has been clear to you related to the base strength where the conjugation and resonance exist, right? So come to the questions. So these are the questions. So here is some questions related to the basic strength between the given species, right? So come. The first question is 1, 2, 3, 4, 5. 5 species are given, and here we have to compare the base strength. This, the NH2, each species have nitrogen atom, and each species is basic because of the donation of the lone pair of electron present in the nitrogen atom. So easily lone pair of electron donated, more will be the basic strength. So here the benzene ring is there. This shows resonance, right? This shows ये alkyl group. This shows plus I effect. Here is this NO2 group, resonance plus, minus M effect, and here is OCS3, benzene ring, delocalization, resonance plus M effect, and here is the neutral molecule. Neither kind of resonance and conjugation is there. So in this species, this is the plus I effect. This increases the electron density on the nitrogen atom, which facilitates the repulsion and can give the lone pair of electron more easily. That means this is the more basic. The first one is this. This will become the first position. Now come to the next. Next is the neutral molecule. Neutral is this. Second. Right? Let me depict a note here. Let me tell you a note here. Notice nitrogen containing species, right? If electron withdrawing group is there, then it becomes less basic. If electron donating group attached to nitrogen species make it more basic, because it increases the electron density to the nitrogen atom, by which it facilitates, due to the repulsion, electron pair can be easily donated. It withdraws the electrons, that means nitrogen lone pair of electron cannot be easily donated, right? So here, come again this side. The first one, plus I effect, increases the electron density of nitrogen atom, more basic. The neutral molecule then the resonance stabilizes. Resonance delocalizes the electrons, delocalizes the pi electrons, lone pair of electrons on nitrogen atom, by which the lone pair of electron is not available to donate, right? So it becomes less basic. So here 3 species are benzene containing 1, 2, 3. So these are less basic. So in these 3, which decreases the electron density more is NO2, because it shows the minus M effect. It decreases the electron density. That means this is least basic, right? That means 1, 2, 3, 4, 5. It will be the 5th position, right? Now in these 2, this is the resonance only, and here is the plus M effect. Plus M effect, actually the lone pair increases in the benzene ring. It donates this group, oxygen, lone pair of electron on oxygen donates in the benzene ring. Delocalization is present. The nitrogen atom having lone pair of electron, the delocalization is present, but this group increases the electron density. That means this is more basic than the benzene ring. That means it becomes the third one and it becomes the fourth one. Hope that relative to these 5 species, concepts has been clear to you, right? Now come to this species. This species here, this species doesn't have any resonance, right? No resonance. And here resonance, and here is also resonance. So in these two are less basic because of the resonance. The delocalization of the lone pair of electron or nitrogen atom delocalizes in the ring, so hardly available. So these two are least basic. That means in between these two, which give more resonating structure, will be less basic because more delocalization of lone pair of electrons takes place. So this is 5-membered ring, so it gives 6 resonating structures, and this is 6-membered ring, so this gives 5 resonating structures. 5 resonating structures, and this gives 6 resonating structures, right? So this is least stable. That means this comes at 4th position, 1, 2, 3, 4, and this comes at 3rd position because resonance is present. Now in between these two, in this species, the nitrogen atom is sp2 hybridized. This is sp2 hybridized, and here it is sp3 hybridized nitrogen atom, right? And sp2 hybridized atom is more electronegative than sp3 hybridized atom. So more electronegative, more strongly the electron held it, right? That means this nitrogen hold the electron tightly in comparison of this. That means this is less basic than this. That means it comes at 2nd position and it comes at 1st position, right? So this is the relative stability order of the base strength in the given species. Hope that with the help of these suitable examples, each and every concept of basic strength has been clear to you, right? Thank you. One more thing I would like to say you, that is, if you like my questions, my method, my teaching method and my descriptions, then please like, subscribe and share. Share to all of your friends, all of your relevant students, right? By which the concepts may be clear to the all students, right? Thank you.